Students, welcome to Learner's Planet, Theory Session 8 of Periodic Classification and of Elements. So, in our previous session, we were discussing about the elements present in the group and their trends of valencies along the group, or the number of valence electrons which are present in the elements. So, what we found was that when we move from top to bottom in a group, what happens? There is no change in the valency. Why? Because the number of electrons in the valence shell remains the same. The only difference there is the number of shell increases. Now in this session we will be discussing about the trends of atomic radius along a group. That is, when we move from top to bottom in a group, what is the trend of atomic radius? So now let's start with our discussion. So now the size of atom or the atomic radius. I told you about this that the size of atom is also termed as atomic radius. Why? Because atom is supposed to be a sphere, or it is circular in nature. So straight away we'll move to the size of atoms along the group. So what is atomic radius, students? It is the distance between the nucleus and the valence shell. We had discussed this in detail. Now I'll only tell you about the trend along the group. Now the size of atoms increase progressively from top to bottom in a group. Why it happens so? Why the size is increasing? When we move from top to bottom in a group, a new shell of electrons is added every next period in the group, due to which the size of atom increases. Let's check out how it happens. See here, atomic radii of group 1 elements. Lithium, it is what? Li3. What is the electronic configuration? 2 and 1. How many shells are there? There are 2 shells only. That is, what is the number of this? What shell would be there? It would be K and L shell. Now, what is the radius of it? It is 1.52 angstrom. The next element in the group is sodium. So, what is the atomic number of sodium? It's 11. What is the configuration? 281. How many shells have become now? 3. What is the radius? 1.86 angstrom. So, what are these shells here, students? They are K, L and M. Now coming to the next shell, that is potassium. Potassium, the atomic number is 19. What is the electronic configuration here? It is 2, 8, 8 and 1. How many shells are there? There are 4 shells. The atomic radius again increased, that is 2.31 angstrom. So 4 shells, K, L, M, N. Likewise, the next is rubidium. Rubidium, the atomic number is 37. What is the electronic configuration? 2, 8, 18, 8 and 1. How many shells? 5. So what is the atomic radius here? It is 2.44 angstrom. Likewise, cesium, the atomic number is 55. The shells would be, the electronic configuration would be 2, 8, 18, 18, 8 and 1. What is the number of electron shells? It is 6. The atomic radius 2.62. Likewise, francium, the atomic number is 87. And students, how many shells are there? 7. And what is the atomic radius? 2.70. So, in all, what is happening to the atomic radius when we move from top to bottom in a group? What is happening? The atomic radius is increasing. So atomic radii is increasing. Okay, so this is the trend of atomic radii. Now moving to the next property, that is the metallic character or the non-metallic character. Now students, what is a metallic character? I'm not talking about the physical properties that metals have luster, they have a shining surface that is luster, they are sonorous, they are good conductors of electricity and heat. But I'm talking about the chemical property due to which they have these physical properties. What is it? That metals are electropositive in nature. Electropositive means they can easily lose electrons. Electronegative means they can gain electrons. So, now while going down in groups 1A, 2A, 3A, the metallic character of elements gradually increases. Say for example, group 1A elements. So what are the group 1A elements? I hope you would have tried to just remember or mark up the periodic table. What are the group A elements, children? These are lithium, sodium, potassium, rubidium, cesium and francium. So what is happening to the metallic character down the group? The metallic character down the group is increasing. So what I'll write here, the metallic character is increasing. I'll tell you the reason of this. So lithium is the least metallic, okay? So here first element and least electropositive, whereas francium is most metallic and most electropositive. So let's see why this happens. What is the reason behind this? What is happening on moving down in a group? A new shell is added after every change of the period. Okay, say if I am talking about the second group elements, that is 2A. So what are the elements here, students? They are beryllium, magnesium, calcium, strontium, barium. Okay, radium is radioactive. Now this belongs to the second group, second period. This is the third period, fourth period, this is fifth period and this is sixth period. Now in beryllium, how many shells are there? As it is second, in beryllium there are 2 shells. So at the center there is nucleus and we have got 2 shells here. The number of electrons in the valence shell is 2. Magnesium. In magnesium it belongs to the third period. So how many shells are there in magnesium? It would be bigger than beryllium. And how many shells would be there, students? It would be 3 shells there. Okay, so there are again 2 electrons but there are 3 shells. In calcium it belongs to fourth period. So how many shells would be there? It would be more bigger, and so the number of shells inside it would be 4. That is, this is 1, this is 2 and this is 3 and the final shell. How many electrons in the outermost orbit? 2. So likewise the number of shells go on increasing, as the result of which what happens? The size of atom increases. We are seeing here. What are these? This is beryllium, atomic number 4, magnesium atomic number 12 and calcium atomic number 20. So what has happened? The size of atom increases. So what will be now? What will happen now? Thus, the effective nuclear charge, which is the net force of attraction acting on the valence shell electrons, gradually decreases. Now what do you mean by this effective nuclear charge? Now let's discuss this effective nuclear charge first. So I'll write here effective nuclear charge, effective nuclear charge. So what could you see here? Say if I draw an atom of beryllium, then I am drawing an atom of magnesium. Magnesium is a bigger atom. Okay, then I am drawing an atom of calcium, which is still bigger. Now what is happening, students? Here I have got the nucleus and I have got only two shells of electrons. In this case, I have got how many shells of electrons? I have got 3 shells of electrons. And in this case, what I have got? I have got 4 shells of electrons. Now what is happening, students? This nucleus is exerting force on the valence shell electron. In this case also it is exerting force on the valence shell electron, that is there are 2 again. And in this case this is also exerting force on the valence shell electron. Now what is the difference in all these 3? That is beryllium, magnesium, calcium. The distance is increasing, so the net force of attraction, the net force of attraction of what? Of nucleus on what? On valence electrons is what? Is decreasing. Now let's see why it is decreasing. What is happening? Why it is decreasing? Say here you can find out that in beryllium, how many shells are there? There are 2. So how many electrons are there? There are 2 and 2. In magnesium, there are 2 and 8 and 2. In calcium, there are 2 and 8 and how many electrons? 8 and 2. So you can find that here also in the inner shells also there are electrons. Here there is only 2. In this case there are 8 electrons inside and there are 2 in the innermost. Here there are 2 layers of 8 electrons. This is also 8. And inside there are 2. So what can we conclude from this? What can we say? That in the inner side there are so many electrons. So there would be what? There would be some force of repulsion also between the electrons. Okay, so what are the 2 types of forces working here? The 2 types of forces are, first is force of attraction between nucleus and electrons, or okay. And second is what? Second is force of repulsion between electrons. Got my point? Now here say what is happening. how many electrons are there? There are 2 and this makes up 10 electrons. So they'll repel also because of the same charges. And this nucleus will attract also. So there are 2 antagonistic forces acting here. Likewise, you can see here, there are so many electrons. There is a force of repulsion between them, as well as the nucleus has attractive force on the electron. So the outcome of this is the net force of attraction. What is left? That is your effective nuclear charge. Okay, so what I can say here is, this is effective nuclear charge is net force of attraction of whom? Of nucleus. Got my point? So that is why I am talking of net, because there are 2 types of forces acting here. Now you can find out in which case the effective nuclear charge is maximum. It is maximum in beryllium because there are only 2 electrons inside. The force of attraction is more. Whereas in magnesium, the force of attraction is less because there are number of electrons inside is more. Here the force of attraction has been further decreased. Why? Because of so many electrons inside. In a way, what you can say, that the electrons are shielding the nucleus. Can I say that? The electrons are shielding the nucleus. Right? Shielding means they're just covering the nucleus. You can see from here. So that is why the net force of attraction decreases. Now as we move down the group, what is happening, students? The number of shells are increasing, and so the net force of attraction is also what? It is increasing or decreasing? It is decreasing. I hope you have understood this concept. This concept is very, very important, students. So you should understand this. Now what was this? Thus the effective nuclear charge, that is the net force of attraction, acting on the valence shell electrons gradually decreases, as the result of which what will happen? The valence shell electrons are loosely held by the nucleus of atom, and so an atom can lose electrons easily, forming a positive ion. See this. Here what is happening? These electrons are loosely held, so they can easily come out. That is your calcium. This what it does, students? It gives out how many electrons? It is giving out 2 electrons and is forming what? Ca2 plus ion. So because of this less net force of attraction, Ca can easily form calcium plus ion. The tendency of an atom to lose electrons, what is it? Metallic character, increases on moving down the group in a periodic table. Say if I am writing the third group elements, that is your boron, aluminium, gallium, indium and thallium. So which would be least metallic? Or boron, it is a non-metal. Aluminium is a metal, okay? Or the metallic character of boron is less. Now, this what will happen? This aluminium is a metal, and what is happening to the metallic character down the group? It is decreasing or increasing. Okay, now say if I am talking of boron, so boron has how many electrons? It has got how many shells, students? It has got only 2 shells. and nucleus at the center. So there are how many electrons here? There are 2, and what is the atomic number of boron? It is 5. So what will be the configuration? It will be 2, and there are only 2 shells. So it would be 3, right? So the nucleus exerts greater force of attraction on the 3 electrons. So it is difficult for boron to form B3 plus ion. Okay. So what happens that it is a non-metal. The tendency of an atom to lose electrons, that is a metallic character, increases on moving down the group in a periodic table. See this. This is the least metallic, or we can say it's a non-metal. We can write here it's the least metallic. That would be better. Because it has got 3 electrons, it can lose them. So I can say here it is a least metallic. The metallic character is very, very less here. Okay, so it is least metallic. Least metallic. Atomic number 5, configuration 2, 3. So beryllium 4. Now this is, I'm talking about beryllium. It is least metallic. Then the metallic character increases and it becomes what? Most metallic. Then is the electronegative character, that is non-metallic character, decreases on moving down the group in the periodic table. That is, as one moves down a group, a new shell is added after every change of a period. I have discussed this. What is electronegative character? It is a tendency to gain electrons. For example, in case of group 7A elements, the fluorine atom or a fluorine atom has only 2 electron shells, whereas astatine has 6 electron shells. If I draw fluorine atom, the size of fluorine atom would be small. But if I draw astatine atom, the size of astatine atom would be big. So in fluorine atom there is a nucleus and there are only 2 shells with 7 electrons in the valence shell. Whereas if I write this thing astatine, there are 7 shells. This is the second shell. This is the third shell. This is the fourth shell. This is the 5th one, and I have to draw 1 shell outside this, though it would not be a perfect circle, but it is the same. So this is the 7th shell, and your 7 electrons are here. 6th shell, sorry. So these are the electrons. 2, 3, 4, 5, 6, 7, and I have drawn 8 electrons, which is actually wrong. It has got only 7 electrons. Now students, could you guess, say, what happens for formation of a fluorine minus ion? This is F atom, and for the formation of fluorine minus ion. Fluorine F atom has got how many electrons? It has got 9 electrons, and F minus has got 10 electrons. So what should happen? It needs to gain 1 electron. So it needs to gain 1 electron. In this case, this is astatine, and astatine has how many electrons? It has got large number of electrons, and so this also needs to gain 1 electron for forming what? For forming At minus ion. Okay, now what is happening? In which case nucleus has more effective nuclear charge? In case of fluorine, of course, because there are less number of shells. So what will happen? Fluorine will exert fluorine's nucleus. Okay, so fluorine's nucleus will exert more force on incoming electron. Okay, whereas in case of astatine, just students, see the distance of this nucleus to the outermost shell. You can make out this astatine nucleus will exert less force. Okay, so it is less force. So which will hold the nucleus tightly, fluorine or astatine? Fluorine. So fluorine will hold the nucleus tightly. Thus, fluorine can easily form F- ions and hence is more electronegative, that is non-metallic in nature than astatine. Now, while moving down in groups 4A, 5A, 6A and 7A, the non-metallic character or the electronegative character of elements gradually decreases. Say here, this is nitrogen, group 5A. Nitrogen is what? It is non-metallic. Phosphorus is again non-metallic. Arsenic is a metalloid. Antimony is a metalloid. Bismuth is a metal. Why? Because as the size is increasing, I can write here size is increasing. Where the size is increasing? It is increasing down the group. So, the size is increasing. As the result of which, what is happening? Nuclear force of attraction on valence on the incoming electron, not the valence. So, on the incoming electron is decreasing. So what is happening? Electronegativity is decreasing. Okay, and the tendency to lose electrons is increasing. So we can say that electropositivity is increasing. Keep these things in mind. This is very important. Now this non-metallic character of 7th A group elements. So what are 7th A group elements? Fluorine, chlorine, bromine, iodine and astatine. So fluorine is non-metallic or most electronegative and astatine is least electronegative. So note one thing, amongst all elements in the periodic table, francium is the most electropositive element and fluorine is the most electronegative element. Students, keep this thing in mind, that which is the most electropositive element? Francium, or you can say cesium, right? Francium is radioactive, so we are not using it in our every chemical reaction. So cesium we normally use, and fluorine is the most electronegative element. So if you have given in your options, if there is francium, you'll mark francium, and if there is cesium, you'll mark cesium. Okay. So which is the most electronegative electropositive element? Francium. And you know cesium is used in your photoelectric bells. That's not francium. So now I'll conclude this lecture, students. In our next lecture, I'll be telling you about the chemical reactivity of elements along the group. Thank you for listening patiently.